All right, guys, so it's Miss Bren's. There's been some problems with this video. I've tried to tape it like 4 times and gotten all the way through the end, and it keeps, it won't save and upload. So I'm trying to make this a little bit shorter so you guys can pause and do whatever you need to do to write it down. But I'm going to already have them right now and kind of discuss them as we are going, just to kind of save some time to make it a little bit shorter video for us to be able to upload. All right, so some things that we talked about last week were those equations, those exponential functions, and we were talking about, we called them y equals bm to the x instead of ab to the x, because we know that b always stands for our y-intercept and that m always stands for our rate of change. When you're talking about what does the m affect, we talk about steepness and direction. Remember, on these numbers that are greater than 1, it means the bigger the number, the steeper it is. And we also said that they're always an increasing graph. When m is between 0 and 1, meaning that it's a fraction less than 1, it is going to be the opposite. It's actually a decreasing graph, and the smaller the number, the steeper the line is. When you're talking about what the b represents, we said that it is the y-intercept. Okay, so m is always your rate of change, and b is always your y-intercept. Something new that we've been working on now are shifts. When you have a constant added on to the exponential function, it actually shifts that line up or down. All right, so let's go ahead and look at letter I and J. If you look at these, it actually says that this one has a y-intercept of 2. It's a number greater than 1, so it should be an increasing graph, and it's going to have a shift of 0. So that, again, it's never going to cross that y equals 0 line. It's going to have a y-intercept of 2, and we're going to have an increasing graph. So I actually don't want you to make t-tables on these. I actually want you to estimate what they would look like. On the next one, it's got again, the rate of change is still a 3, so they're actually going to be the same steepness, but my y-intercept is changing, so it's going to cross the y-axis on the 1/3, again with the shift of 0, so it means it's never going to cross that y equals 0 line. It's going to be an increasing graph crossing on the 0. Again, I will give you guys time to copy these down. You can pause anytime you would like. On the next ones, we have a coefficient of 1, actually, even though you can't see it. So my y-intercept is a 1. It says that it's going to be just a little less steep than the last line because it's a 2, but it's still in an increasing graph. And this time it's going to shift everything down 3 spaces. So what should have been a y-intercept of 1 is actually getting shifted down 1, 2, 3 spaces. And again, it's never going to cross that y equals -3 line, and it's an increasing graph, so you can draw it that way. Same thing on letter L. Again, our y-intercept is supposed to be a 4 up here, but it says that it's shifting it down 5 spaces. 1, 2, 3, 4, 5. So it bumps it all the way down to there. And it's, again, same steepness, and it's never going to cross the y equals -5. All right, so I want you guys to try m and n. Again, same thing. You have a y-intercept that was supposed to be a 1/4, but this time everything got shifted up 3 spaces. It's never going to cross that y equals 3 line, and same steepness as the last 2. Now this last one's a little bit trickier because it's a decreasing graph. Y-intercept was supposed to be a -1, but it got shifted up 2 spaces, up to the +1. And again, it was supposed to be a decreasing graph, but it's a negative, so it got flipped upside down. Think about those reflections, and you just flip it upside down. Okay, so on the back, you're talking about word problems. And again, what I like about these word problems is that these are already given to you. You're not actually writing them yet. So it says you can read the situation, and it talks about when will it be a good domain and a good range. Well, we're dealing with years, so years cannot be negative. And we're also talking about consumption of soda. You can have a 0 consumption, but you can't have a negative consumption. On these, I just made a t-table and plugged in some values. Says what will the soda be at 2005, which is 5 years after 2000. Plugging in a 5, I get this as my answer. Now this, when I graphed it, it actually almost looked linear, but it's just slightly curved. And so the more, the bigger the numbers got, the more the curve would be, but it's still a slight curve. Okay, and then we have the bacteria one, same exact thing that I did. Now this is talking about 20-minute increments. So it's 1 20-minute increment, 2 20-minute increments, and so on. So when you're talking about 2 hours, it'd be actually 6 increments, 6 20-minute increments. 1 increment, 2 increments, 3, 4, 5, and then 6. 120 minutes is 2 hours. When you're talking about a table, exponential patterns will have a multiplication pattern. Remember, linear were those addition patterns. So that's what you're going to be looking for in those. Again, I do apologize that the notes kind of were not me going through them problem by problem, but again, I did it 4 times and it would not upload. So this time we're going to just do a short 6-minute video and we can hopefully get that to upload a lot easier. So good luck, and I will see you guys on Wednesday.